Hello, I'm Shaf Rahman. I'm the Director of Marketing from Akros Silicon. We are located in Sunnyvale, California. We started this company about 5-6 years ago, but we are shipping about 4 different families of products in mass volume production right now. And we are here in Electronica with a demo to show one of the products that has very high value propositions. This product is what we call the AS18X4 and the AS14X4 products. They are primarily power management solution products. One of the products, this one, the 1800, is for power over Ethernet. So what is the power over Ethernet means? It means that right now, if you have an IP phone or a security cameras or wireless access products inside your home or outside your home, 2 cables going in there. One cable is to power up the device, another is for the data transmission. What this solution allows is to combine those 2 cables into one cable through the Ethernet. Now I'm going to be able to pass the power from the PSE, what we call the power systems equipment, to the end devices. Okay, so one cable goes in, it carries the power and the data. That is what this product is all about. Now, in the industry, there are some solutions, but it takes about 9 different components to do the same job. Here, we're offering a SoC solution, which can be used to provide the entire solution just through one chip. Okay, so I would like to show you how this chip operates and what the functionalities are. Now, these products, it comes in the hardware version, also in the software version. And software means that it has I2C interface through which you can control the primary side, which is the high voltage side, from the secondary side. So I would like to direct to the diagram now for me to explain how this product works. So here I have a primary side on the left-hand side and the secondary side on the right-hand side. Primary side, now by the way, the Ethernet standard, they already came up with 2 different standards, .AF, which is the 13 watts, and .AT, which is the 30 watts power solutions. This product can handle both of those, 13 watts and the 30 watts. So the voltage can fluctuate somewhere from 48 volts to 57 volts, but sometimes it has a provision to go to about 72 volts as well. The standard allows that fluctuation. So I am going to be bringing in here in the demo also a 48 volts input, and then we'll show you how the output rails show up. Now, you can bring in a 58 volts to about 57 volt, goes through the digital isolation, the data comes in. All we do with the data is that we just pass it back to the network. We don't touch the data. All we do is bring the power down and do the conversions and then spit out to the output rails. That's all we're doing here. And it goes through the digital isolation, which is a very big part of our technology. It can sustain from 2 kV to 4 kV digital isolation. Digital being the word, meaning that I can access everything from the secondary side to the primary side without any problems. It has all the connectivity except the grounds are different. Okay? That means I'm operating the primary side, which is the high voltage side, from a safe side, which is the low voltage side, from the secondary side. Now, this particular part has 4 output rails. I have a first rail. By the way, the efficiency is very, very high. Going from my input voltage of 48 volts, when I go into the first rail, it gives me about 93 to 95% efficiency. And then the first voltage, which is about 5 volt, then gets fed into the other 3 rails. The second and the third rails are bucks. The buck, the definition of the buck is that whatever voltage is coming in from an input, it can go down. Okay, so you bring in a 5 volt, it steps it down to 3.3 volt or 1.2 volt. And then the fourth rail can be used as a boost. That means whatever the input voltage is, let's say it's a 5 volt, I can boost it up to 12 volts all the way to 30 volts, right? So because on the board, you have devices that requires different input voltages. So that is the idea behind having 4 rails, providing 4 rails at different voltages and the currents, right? So you can set it up with by varying the capacitor and the resistor values. You can set up the particular rails to a particular voltage and the currents. So what I will show you is this. For example, the hardware is on the first rail, for example, I have I show a 5 volt, clean 5 volt, okay? Then on the second rail, I show a 3.3 volt, okay? By design, I have implemented that. On the third rail, I have 1.5 volt, a clean 1.5 volt. And on the fourth rail, as I said, it is a boost that I'm feeding in 5 volt and I'm getting 12 volt. I can go up to 30 volts as well. But that's just the hardware portion of it. Then you see this little card over here. That's the I2C interface. Through that, I can control many things after it's been designed in on the hardware. It's already in the board. Everything is boxed up and shipped. Now I can change many aspects of these designs, okay, the functionality through the remote monitoring, through the I2C interface. What are some of those things that I can change? For example, if you look at it here, I can do voltage margining. Okay? So voltage margining means that it was set at 5 volt from the hardware side, but can I change it slightly to another 5% delta or 15%? Can I go to 5.25 volts? Because certain devices may need that, and you don't want to go and change your hardware for that. So it gives you the provision to do the voltage margining for all the 4 rails. It gives you the provision to do the P good. P good means that I have set it up for a 5 volt, but if it goes below that, do I want an alarm? Okay, I2C can give that alarm. And then also like an internal over temperature alarm. The device, if it goes above 125 degrees C, it can give alarm. Okay, so I can set up to give the alarm. So this is just a few of the things, but there are a lot more other features that you can control through the I2C. Okay, so that is basically the demo. We have 1800, which is the PoE solution. 1400 is the non-PoE solution. You know, there are a lot of cases, for example, the wireless access products that are sitting at home inside, that have access to a power inside, right? So it doesn't need a PoE solution, but what it needs is a power management. The other aspects where you're taking a high voltage input and speeding out multiple output rails. So a 1400 series can be used for that. From our company, this is couple of families of products. We also have 1100 series, which we have been shipping for the last 4 years. We are currently doing business with some of the top IP cameras, IP phones, all those types of customers. Okay? Thank you very much.